Thanks for coming. It's great to be here. I love living in Austria. It's been a lifelong dream for me to live here, to be here. And it's a tour that I'm doing right now. I was visiting Salzburg and then Linz, and now I'm here. And I hope to have many opportunities to come in and work with you. And I want to share a little bit with you about my own journey. One of the nice things about having a career transition from a place like Hong Kong to a place like Innsbruck is that you really get to reflect on what is it that I care about, what is it that I want to do, where do I want to spend my next 5-6 years. So a lot of changes, many different things between Hong Kong and what I was doing over there and what's happening over here in Innsbruck. Open science, meta research, and it seems like in Austria, there's a very good, strong group of people who care about these things. So it's no longer me being the outlier and telling everybody, hey, there's this thing called open science, you should care. Now there's a good group of people who I can collaborate with and we can do wonderful things together. So for this talk, I was asking, is there anything you want me to talk about? And typically people say, hey, can you talk about your applications? Can you talk about open science and all this? I will talk about these things. But Robert, let me talk about whatever it is that I want. So I'm going to tell you some stories about this process that I've been through, moving from Hong Kong to here. And what is it that I discovered along the way, and what is it that I'm passionate about or that I'm trying to create? And I'm going to go through a lot of different ideas. They might be a bit scattered, but hopefully you'll find some logic in this. And I just want to say, everything that I do is collaborative. You're very welcome to come and talk to me about all of this. I'm going to spend some time here tomorrow, and hopefully I'll come back many more times to Vienna. You're always welcome to hop on a train and come visit in Innsbruck. So I'll just very briefly recap. What did I do with the University of Vienna before? So last time that I was here physically, 3 years ago, we did this talk where I was not really sure what I'm doing, but I just took this as an opportunity to throw some ideas out there. And I was talking about this doing more good and doing good better. And I wasn't really sure where do I want to take this. I just knew I'm coming out of a pandemic. In Hong Kong, we had it really rough with the zero COVID policy. I spent 8 quarantines, 2 or 3 weeks, one time in a government camp, but also in a hotel, just stuck with myself in a room thinking, what is my value? What is my impact? And I realized I don't have a good answer for this. And this is something very troubling to discover about yourself and your research. And I decided I want to do more good and I want to do good better, but I don't really know how to do this. So I came over here and I talked about some directions with effective altruism or ineffective altruism, about how people think about charitable giving. And I threw some ideas about me trying to do some applications with identifiable victim effect and some other stuff, and not really understanding what this literature is going and what I want to do. So I'm going to share some things that follow up from the talk at the University of Vienna. And then later, some of you said, hey, you're doing register reports and you're doing peer community. Can you give a workshop on this online? So we did this. So this was December in 2024. So that was nice that people attended and we did some stuff with this. I prepared a survey for you to answer this kind of thing. And I was going to ask you some questions about, I can't remember exactly what, but I was going to ask you, which one is the closest to how you feel about AI? So some common responses are like AI everywhere. Enough with this AI, already boring, or I can't get enough of AI, keep it coming, or who cares, another overhyped technology, or I'm intrigued, but I don't know enough. So if you want, you can scan this in order to come in. It's a little bit small. And then I had more questions like, which of the following is the closest to how you experience AI? So I'm just going to... I think it says the presenter hasn't started. Yeah, so I'm going to start this. Present, and now you can answer this if you want to. What is this platform? Do you know this platform? It's a little bit like Mentimeter, right? If you know Mentimeter. But I created this platform with an AI very, very easily. And I can see actually it works like Mentimeter. Every time I run this in my classroom, my heart beats like, is this going to work? Is this AI stuff solid? AI created this in no time. So what, in order to create a Mentimeter, you would expect that it's like a whole company and it takes 100 employees. And I created this very, very, very easily. So you got like all these responses. I'm intrigued, but I don't know enough. Okay, great. So now we can move on to the next question. And the next question is, which of the following is the closest to experience with AI? I only use AI with a chat interface. I use AI with an IDE, CLI, Codex, Claude. So there's many different ways to using AI. And most of the experiences that I get from people when people hear about AI is like, okay, so I use ChatGPT. I asked for all kinds of things with ChatGPT. It gave me some hallucinations and references that don't exist. therefore not good for science. And it seems like at least 11 of you, this is your experience. And this is a shame. And this is good that we're talking about this because you're losing out on a lot of things. For example, creating this website, you could create this website and you cannot do this through a chat interface. You really need to know how to install VS Code or Cloud Code or Codex for ChatGPT. You can create these things yourself, and there's so much potential for you to doing solid research. And then I'm going to move to the last one. Which of the following is the closest in terms of accuracy? Do you think that accuracy, humans are superior and we need humans to code everything? Or do you think they're a bit like humans? Or do you think maybe AI is ready and we're already there? So I'll give you a second to think about this. Okay, thanks for playing along with this. I wasn't sure if this is going to work out, but it did. Who knows if these AI developed tools are going to work out. But one of the things that I had at University of Hong Kong is access to Mentimeter, site license. I go to Innsbruck and like, what is your Mentimeter? I said, sorry, we don't have one. So I said, no problem, give me 2 hours. Well, now I have a website that does Mentimeter, and you don't need to pay $1,000 a year in order for me to have access to this. So this is the #1 thing that you can do with AI if you know how to use this. Spawn off agents, get it to clone all kinds of things. I'll talk a little bit about this. I created all kinds of different websites. But it does seem like there's skepticism. Or at the very least, it seems like, okay, maybe humans, LLMs can, like, on par. We can do something together with them. But most of the times when I present these kinds of things, people are like, no. LLMs are not ready. Our experience with LLMs is that it's very bad, and we always need to have human coders in the mix. And I'll address this. All right, so we'll go back to this. Thanks for participating. This is great. So I'll go back to this doing more good, doing good better. So this came out in 2024, so just after I visited here. We did a registered report. And because I do a lot of registered reports with undergraduate students, so this was with Manix, and one of the registered reports that we did was trying to understand, what does it mean to do more good? What is good? And what does it mean to do good better? It's exactly what all these things mean. So he found this really interesting book chapter, and the book chapter was trying to map out all kinds of cognitive biases in the way that people do charitable giving and the way that they do philanthropy. And it was mapping out all of these perceived waste, past cost, in-group, out-group. So it does seem like whenever we donate, if we see something that is here in Vienna versus if we see something that's out there, I don't know, in Brazil or Global South, then we tend to donate more to people that are around us. And at least in the literature, this seems like some kind of a bias in a certain direction. And this was already interesting to me because it had a very simplified paradigm. And the paradigm is very classic judgment and decision-making, which is what I specialize in. And what it gave you is there are these two charities. They're exactly the same in every possible way. You get 10,000 euros, US dollars. How would you allocate between these two? And then there's this, maybe there's an example. So over here, this is an example for you to think about. So exactly the same, they both prevent 5 deaths for every $1,000 of donations, but there's one difference between them. There's one factor. And the factor is just how much they spend on overhead. Overhead is like bureaucracy on management. Yeah. So it seems like charity A spends $200 out of 1,000, and charity B spends 100 out of every 1,000 on overhead. So if people really don't care about this, they will allocate equally, 50-50, right? But if you have to answer this, first think for yourself, how would you answer this? Then think, how would other people answer this? Would we expect any deviations from a 50-50 spending? So what does your intuition tell you? Sorry? B, why? They both 1,000 US dollars save 5 deaths. So the efficacy, the efficiency is exactly the same. The only difference between them is how much they spend on overhead. So efficiency is the same. What do people care about overhead or not? Do we care?
I think if you find whatever
yeah, so there's all kinds of different ways to think about this. You wanted to say something?
We only need dollars to identify deaths. So I think that's more efficient.
Very good. So I really like how you're thinking, and I think this deviates a little bit from how laypersons are about this. But when I ask people, when you see this kind of dilemma, what do you envision? what is overhead to you? And they say, overhead, this is like massages for CEOs. We don't want to spend our money on giving massages to CEOs. We want our money to do the most good possible. So when we look at the distribution, we put a general t-test, we see some kind of a deviation towards the charity that spends less on overhead. And people are like, most of them say, I don't care. But most of them say, we don't want to spend so much on overhead. And we have the same kind of thing happening with marketing. And people just don't like this kind of direction. And then you can ask, is this effective or not effective? And you already came up with a very good answer that if you reframe this for people and you tell them, okay, forget about the overhead. Just look at the efficacy of what it is that they do with the money that doesn't involve overhead. When you give them this scenario, they answer very differently, right? But there's something about overhead that gets people to go crazy. It's like, we don't want our money going for CEOs or for bureaucracy or for all of these other things. But we know, even in a university, when we get a grant, some money goes into admin. So we have rooms and we have a projector and we have all of that stuff. So what can we do with this? Very simplified scenario. You're thinking to yourself, what can we possibly learn from this? These judgment and decision-making scenarios have nothing to do with what happens actually in the field. But this scenario, for example, started something very, very important because there's a science paper that came out with Genizi and Genizi. And Uri Genizi and his wife Ayelet and another co-author published this in Science. So this is the science paper over here. And there's also a successful replication with some of my colleagues in Innsbruck about this behavioral economics mass replication of all the papers in Science and Nature. And what you can see basically in the science paper is that they realized that people have an aversion to overhead. So they said, how about you have an option where all of the overhead is covered by the Bill Melinda Gates Foundation or Warren Buffett. Somebody else is going to take care of the overhead. Your money is the one that's going to do the most good. Would people donate more? And it seems like, and we don't see this often in behavioral change, correct me if I'm wrong, control condition is here, overhead is here, a boost of 2.5 times. People donate 2.5 times more if you tell them that overhead is covered by an external donor. So already you have a very simplified scenario with a very simplified charity A versus charity B, where you have an insight. And from this insight, we take this insight, we replicate this, and then we run this in the field, and then we realize, oh my gosh, we can boost donations by 2.5 times. This is not small. So I really like this kind of thing. When I start the book chapter, I'm just like, okay, we need to replicate this. Mannix did a really good job, an undergraduate student. We found support for everything in this book chapter, and then he added extensions. And this is already terrific. So this follows up on my previous talk, doing more good, doing good better. Maybe we can do more good if we just understand all of the cognitive mindset of everything regarding philanthropy, and then we can devise all kinds of behavioral interventions in order to address these kind of things. But then I was thinking, wow, this is a lot of effort. So we've got one thesis student. Our register report took us a year in order to get everything done and published in a journal. Too slow, and this is too narrow. Can I scale this up? How to scale this up? And this is when I thought, how about I just get my students in my courses, instead of running replications, I'm going to crowdsource. So after I left here in Vienna, I went back to Hong Kong and I said, we're going to use this paradigm, but I'm going to ask my students, you come up with what you think are the strongest factors. Let's do a competition. You bring up your best factors, between 10 and 20 different factors. Let's run a competition. The best ones get a bonus. And then you'll see that we had 12 different teams. My students came up with 90 plus hypotheses. And it's amazing that some of them have never been tested in charitable giving and donations in the literature. We mapped those up, and then we put them all together, looking at the efficacy in Cohen's d. So this is a one sample t-test d with this allocation 50-50. Does it deviate from the 50-50? And then I wanted to see which one are the strongest factors. Now, if you look at the literature, what is a typical Cohen's d even for one sample t-test? In judgment decision making, it's 0.5 to 0.8. Cohen's d of 2.24, 1.78. So some of these factors show a very, very strong bias. So what kind of bias do people have? People are very risk averse. People really like transparency and information. So they will go for the charity that gives them more information about what it is that they're donating for. Some people look at neglectedness. They look at reputation. They look at whether this is the in-group versus the out-group, whether this is close to them or far away from them. But now, for the first time, instead of doing 4 different factors or doing, I don't know, Mannix added 3 more, so I have 7, with one student, now I have this method where I can just collect all of these together and run this. So I did this in the first semester. And then I did this in the second semester. I have 5 more teams with 30 more hypotheses. And I did it in the third semester. So now we have 60 hypotheses, 5 teams. So now after 3 years, I have a mapping of 150 different hypotheses, mapping out the charitable giving domain of how do people think about charities? Are there any biases that we should worry about? And then I can look at all the effects. And even in the third one, where I told my students you cannot repeat any of the factors from previous years, even here you can see still effect sizes of 1.71 Cohen's d. So these seem to be all possibilities for a field experiment to follow up to see, can we use these biases in order to do more good or to help people understand how they do charitable giving? But even after 150 of these things, I thought to myself, this is too slow and this is too narrow. What is it that I can do in order to boost these things up? So after I had all these insights, I still was hungry for more. I wanted to know whether I can really leverage this in order to do more with these things. So even this is too slow, even this is too narrow. So I was looking out there in the literature, what is it that I can learn from in order to really scale up? Not just my course students, but I want everybody to participate. I want to think about all different factors that I've never thought imaginable, not psychology students, not banking and finance students. I want to go as broad as possible. So this is the thing that inspired me, the moral machine experiment. I don't know if you're familiar with this, but this is a Nature paper that came out. They ran this with all of these places around the world. How many were there? 40 million decisions in 10 languages from millions of people, 233 countries and territories. And what did they do? They did trolley dilemmas. So you've got A versus B, and you need to choose which one. The trolley is heading a certain way. They did this because now we have self-driving autonomous vehicles, and they said doing one trolley dilemma and doing another trolley dilemma and doing one paper and doing another paper is too slow. It's too narrow. We need to scale up. So what did they do? They did a platform, and in this platform, you have all possibilities. And they invite people not only to participate, but also create their own trolley dilemmas. And then people get very excited about this. So they create their own trolley dilemma, and then they invite their own family and friend and say, hey, I created this trolley dilemma. It's really cute. It's the cat versus the dog. Are you going to run over the cat or run over the dog? Or you got an elderly or a pregnant woman? Or you have millions of different variations, but people get excited about this, and they invite their own participants. And this is how you get tens of millions of participants. By now, they have hundreds of millions of participants over there at MIT. And then when you map out the cognitive mindset and all the behavioral biases, you see all kinds of things like preference for inaction, sparing females, sparing the fit. People who are more fit are more likely to be, I don't know, just very curious stuff. Whenever you look at these moral machines, I look at this paper and I'm just like mind blown. Over here, you've got what people care about. So between a cat and a dog, there's a criminal. People will run over the criminal. Dog is more important than a criminal. And then you've got like all these different biases. And I thought to myself, this is terrific. I want to do something like that. And actually, we can tackle a lot of different things in judgment decision-making in order to map out a cognitive mindset of anything. Here, it's about a trolley dilemma, action versus inaction, and this person versus that person. But we can also do this with charitable giving. So I spawn off an agent to say, hey, can you create these moral machines for me with this kind of charity A versus charity B? And he did. So now we have this platform. It's called AltruismChoice. And I guess I can show this to you, but we're not going to go into this. You're very welcome to go in this to participate. My students right now in Innsbruck are designing, just like in previous semesters, they're also designing factors. But here, there's also a viral component to it, because not only do they design a component and they give this to me, and then I run the data collection with Prolific, but I tell them, this is your factor. You should be proud of it. You go out and get some other people. And now I see this is like a viral component. I really hope it doesn't get to 10 million people right now because I'm paying for the server. But after I transition this to something different, hopefully, this will have a lot of participants. And the nice thing about this is it's not just the factors that I have, it's not just the factors that my students have, but anybody who comes in can suggest a factor. The AI goes over this in order to make sure that this is not abusive in any way and that this makes sense. It already loads up all of the suggested reading, and then it puts it in the system. And then it also offers you behavioral insights. So after you participate in a few vignettes, it gives you your charitable donation profile on what is it that you care about. It allows you to compare between you and others. So it's just like a very simple thing that we can do if we have this superpower of AI to move from one replication or one classroom with a few students doing hypotheses to now we can scale up now we can invite everybody in order to create their own vignettes, to invite other people to participate in their own vignettes. So this is something that's very promising, I thought. How about other domains? So I thought to myself, if I can do this with charitable giving, maybe I can do this with something else. So now that I have this class in banking and finance, so what can I teach in banking and finance? Not much. I can teach nudging, behavioral change. So these are my nudging course students. I was telling Robert before, it's like, my students in Israel really, really care about health and exercise. It's like health fanatics. They are so much into sports, ski 2-3 times a week. They run, they cycle. I cannot compete with any of this, but I thought maybe I can leverage this. So in terms of nudging, I thought to myself, before we go and recommend policy nudging to, I don't know, governments, how about they experience nudging on themselves? So I gave 2 first sessions with nudging happiness, and there is a course in Harvard, Laurie Santos, about the science of happiness. I don't agree with everything that she's doing over there, but I thought this is a really clever idea. It's the most popular course ever in psychology, more than 1 million people after it was shared in all kinds of online platforms. So I was looking, trying to learn from her, how did she do what it is that she did? And then I saw that she had this app, it's called Rewhy. I thought to myself, I really want to use this in my class. So I went to look at the Rewhy. Rewhy is short for rewire. Can we rewire our behavior? And then I saw that it's been dead for three years, so it's not there anymore. So what did I do? I spawn off an agent. I say, hey, AI, can you go and do a comprehensive review of all of the apps that do anything regarding behavioral change in or nudging in terms of health, happiness, well-being, and all of that. And it did. And then I was discussing with my students about all kinds of things about what is it that we care about, and we have all these kind of nudges, timing the habits and reminders and friction adjustment and all of that. And then I thought to myself, let's get the students to use this. I want them to experience this on themselves before they try anything else. So here's another website created by an AI, done within 1 day, and now the students are using this. And it's amazing to see what happens when you have only 30 students logging in daily. What is it that they do? So you have different domains. I don't know if you can see this, but you have things like exercise, health, sleep, social connection, gratitude, wise spending, whether you spend more on time or you spend more money, work-life balance, and all kinds of daily basics like how much you drink water or how much read a book or something like that. And the nice thing here, a little bit like AltruismChoice, is that the students can come up with things that they care about. So the nice thing about this platform is that it learns from the participants. So if the participant is missing something, it can say, hey, but actually there's something that I really care about, like drinking water. It's not in the system. Can you add this? And almost immediately, I can add this. And I can decide whether people can enable this, disable this, what they can do with this. But I have a platform that allows people to log every day what is it that they care about. So this is the screen over here. And they can add notes and they can do all kinds of different things. But this is not enough for a nudging course. So then I added a few other components. For example, here you can see goals. So people can say, I only sleep 6 hours a night. I want to sleep 6.5 hours a night. What is it that I can do? I can set a goal for myself. So you can say, within the next month, what I want to do is I want to move 1.5 points higher on or half an hour more on sleep. People can set goals for themselves. So already this is something very valuable. And I've never seen students more engaged with anything that I've done in my courses. Besides this app. This app is definitely up there on the top. After goals, they can set nudges for themselves. And they can set nudges for themselves on an individual level or on a team level. So individual level is reminders, temptation banding, and all sorts of other self-nudges. On a team level, it could be like whether you have a commitment to your team. You know, they all have a pact of whether they want to do this or not. And what you can see already is that you have like an export thing. So you can download all of your goals. You can download all of your data. You can download your individual data, and you can download an anonymized, de-identified team data and class data. And at the end of the semester, what is it that they do? They analyze themselves, they analyze their team, they analyze the class, and they learn a lot from nudging. Not something hypothetical that is in a book, but they look at themselves. They look at others that they care about around them to learn what is it that they can do in terms of goal setting, nudging, and maybe also improve their own behaviors, improve their own health and exercise and sports. So students are very passionate about this. Both AltruismChoice and this have an instructor mode. So if you want to run this in your class, you can set up a classroom. You can invite all of your students. You can play with this in order to give me some feedback and see where we can go with this. Is it clear? Yeah? All good? All right. So when I saw that I can do this kind of thing, I thought to myself, I really feel like I have a superpower now. So if I can do these kinds of platforms that used to really take a big team of developers and I needed to buy expensive commercial software, then I needed to apply for funding, maybe I can leverage this further for some of my activities now that I am officially an open science meta research professor over there in Innsbruck. What can I do with this? So it started from this guide. And this guide actually I did with Chinyu. So when we started doing replications back then in 2018, and Chinyu was attending some of my classes, I honestly did not know much about effect sizes. I was doing things in meta-analysis, coding, replication, correlations, and maybe a t-test, a Cohen's d. So you can see Chinyu and Kit, second and third, over there in a very large collaboration. It started just the two of us, and then Kit joined in, and then it was a Google Doc. So everybody that comes in and everybody that contributes becomes a co-author. And then some of the people that joined us along the way, it's amazing, but they're very knowledgeable people. So for example, Matt was the advisor for Psychological Bulletin. So whenever you would submit a meta-analysis to Psychological Bulletin, so Blair Johnson is the editor, so he would sign other editors, and then he would give this to Matthew Jane in order to make sure that your effect sizes are good or not good. And then Matthew really helped me and Chinyu to boost this up to, I think, to be one of the best guides for effect sizes and confidence intervals. So if you want to know more about how to do effect sizes, confidence intervals, this has been running for a while now. This is by far my best cited work. I think last year, like 80 citations. People use this, and it's not even published. This is a preprint book, right? So it's amazing how people use this, and it has in it reproducible R code in order to run this with certain packages. What is the problem with this? Even though very widely used and very nicely cited, it's really great. But most people, when I tell them, hey, look up this this guide, they're like, what do you want from us? This is like 300 pages. We don't even know where to start looking for this. And then you give me 12 different variations of Cohen's d. Forget about it. I don't even know. And it has equations. Oh my gosh, equations. The last thing I want to do is look at a book that has equations. So I thought to myself, a book and a guide is a good step, maybe for me and for Chinyu and for Matt and for Blair. But for people, they need solutions. They need an infrastructure. So what is it that we can do in order to offer them this kind of infrastructure? So I created tools. And this was not easy to do. Perhaps you're familiar, but Michelle over there in Tilburg University created a tool that now is quite widely used called StatCheck. What did she do for her PhD? She created this package. You upload a PDF. It extracts all of the text from the PDF, and then it checks something very, very simple, whether the statistics match the p-value. And then I asked her, this is great. It already caught a lot of errors, and when she scraped 200,000 articles, she found that, I don't know, 7% or something ridiculous like this have issues with their p-values. And then I asked, can you do this for effect sizes? Here's a guide. Can you do this for the guide so that people can check their effect sizes and confidence intervals? It's very, very difficult because you have so many different flavors of every possible effect. And this is even before you go into the confidence intervals. So it's a nightmare. StatCheck by itself was already difficult enough. To do effect sizes, impossible. And when I was consulting with people, how can we turn this into a tool? They said, forget about it. Too complicated. But 8 months ago, when I discovered my superpower with AI, what did I do? I said, hey, AI, let's sit down, talk together. Can we create a tool? So now I've got ESCIMate. And what's nice about this is that you upload a PDF, and it will check everything that you do with the effect sizes and the confidence intervals. Once I realized that I can do this, it's more complicated than StatCheck, but you can see the different categories: consistent, verified, needs like warnings, notes. You've got different categories. Upload your stuff and just see what it gives you. So the nice thing about this, it's really reproducible. So it tells you exactly what it gets the effect size. It tells you exactly what kind of variant it detected. It tries all the different kinds of variants in order to see maybe you had some assumptions that it didn't have. So it tries to give you as much benefit of the doubt that you know what you're doing. But if perhaps you have some kind of a deviation, then it tells you, hey, you might want to check this. And unless it doesn't find any match for what it is that you're doing, then it says error. So already a very nice tool. I use this with all of the manuscripts that I run with my collaborators. But then I said, okay, maybe we can do more than this. So one of the things that I need to do with all my collaborations, I am the corresponding author for a lot of manuscripts with a lot of students, and some of them don't even know citations, references, APA style, version 7, version 6, what is it we need to do? So I spent a lot of my time having to go through manuscripts in order to check very simple things like do all the citations match all of the references? There used to be a free tool called ReciteWorks, but then after a while, I think 4 years ago, they said up till 5,000 words only, and that was frustrating. And then I was trying to find some other tools, and you can do a little bit with Zotero, and you can do a little bit with all kinds of other checks, but all of this was missing. Once I got this superpower, I said, I am going to build this citation matching. So between the citations and the references, now you've got SciMeto. But what you can see here is that actually it has 21 plugins. It started from just matching citations to references, but then I came up with all sorts of different ideas saying, wait, we have some other issues with references. For example, sometimes we have hallucinated references. Now we have a big problem. Maybe we can check that. Sometimes people put references, but they don't put the DOI. We can help with that. So cross-ref, take it, import. Sometimes we cite retracted references. So now I can go to Retraction Watch, get all of this, and see if I'm citing something that was retracted. Expression of concern, tortured phrases. Because I'm extracting, and because I have something that takes all of the references, now I can do more. So I added more plugins, and then I said, maybe I can take all the ESCIMate and use this as a plugin over here. So you just upload your manuscript once, and then it checks everything for you. This used to take a very large team in order to get stuff done. Now I have a way of doing this just by myself based on all the superpower that I gained. Once you start looking into these kind of things, it looks very simple because now I'm telling you about all the, the end result, but the process was not as straightforward as that. So for example, I realized a lot of very frustrating things about science. What is one of the biggest problems that we have in science, aside from not having open access to the things that we did? So once you get over all the publisher stuff and how do we scrape a literature and all of that, what is the big frustration? It's all in a PDF, which is the worst possible file format for science because it messes up everything, right? Why do we share things with PDF? Why can't we just have this in a machine-readable way where we can just download things and analyze them? So in order to get the first two tools, I had to build another set of infrastructure. And I thought to myself, this is science, somebody figured this out already. So I tested, and this is another thing that I did with AI. I said, I'm going to test everything. And people told me, Grobid, open science, open source, everything. Grobid is horrible. It's really, really bad. The best solutions that we have are just very dysfunctional. Now that we have AI, I can create deterministic tools that would be improved all of the time by all these LLMs. So I had needed to create a tool called Docpluck. So if you need to extract anything from a PDF, now I also have a tool with an API that is free, and you can use it in order to get the text. You can get tables. So formatting tables from PDF, making sure that the columns are not there, that the headers don't appear again and again. Difficult stuff, but with AI, improving slowly, learning slowly. Now I have one that is, hopefully, I think, one of the best deterministic tools out there in order to get text from a PDF. The question that I often get when I suggest people, hey, you should use this tool, and this is a very good thing that I spent a lot of time thinking about. It's like, how do we know that you're good? How do we know, compared to Grobid, compared to other solutions, or ChatGPT, we just upload our manuscript to ChatGPT, and we want to extract the references, and we want to extract the text from and it gives me something back. How do you know that your tool is better than the LLM, is better than Grobid, better than all the other solutions out there? So I needed to come up with my own way of proving that my tool is better. And then I thought to myself, why don't we have this in science? That when we claim that one solution is better than another solution, that we can prove this. So if you're saying that your efficacy or your solution or your reproducible manuscript or your effect size extraction or whatever it is that you do is better, how do you prove it? So I needed to come up with my own kind of concept. So I came up with ScienceArena. I have arenas for all kinds of different functionality that I needed to create. So for example, text extraction from a PDF. I'm going to synthesize, simulate a lot of PDFs. Some of them are not going to have any problems. Some of them, I inject errors in them. And then I know for sure that there's an error there because I created it. And now I can set off all of these tools against each other and see how well they do with this. So for example, for stat extraction, ESCIMate, which is my tool, versus StatCheck, let's say for p-values, versus the best Claude Opus 4.7. Which one does the best? In all kinds of different things. And one of the things that you can see, for example, aside from this being free, is that it's very, very fast. So the latency for ESCIMate is 0.3 compared to StatCheck that takes a little bit longer. Why is this longer? Because it uses Grobit, and Grobit is very, very, very slow. Versus Cloud Opus, not only is it expensive, but it also takes 22 seconds to do this. So if you want to scrape an entire literature, that's going to take you some time, right? 200,000, come back in 2 weeks, maybe we'll have an answer for you. And then how do you know? Hallucinate, not hallucinate? At least this is deterministic. So here we have like a composite score, and then I have all sorts of things like notations, OCR noise, density. I created a lot of brainstorming back and forth with AI in order to, if we want to know as science whether we're doing well or not, whether we're improving performance, whether this tool is better than that tool, how do we do this? We need to have competitions. We have to do arenas. So now I have arenas for every tool that I'm creating. And I feel like this is the most important direction, perhaps, of all the things that I'm doing in order for us to be able to evaluate science. We have a lot of claims like open science is better. How do you know that this is better? Have we evaluated this? Did we put this to an empirical test by science in order to make sure that this is much better? We have one randomized control trial by Center of Open Science here. We have another claim over there. But we need to do things rigorously in order to prove to people that this actually works well. So I feel like this is an important direction. I also realized that once I have this infrastructure, now I can go very large scale. So for example, if I have ESCIMate, I can do what StatCheck did. So instead of just checking one manuscript or checking what my collaborators are doing, I can scrape an entire literature. So here's an example from one of the manuscripts that is mostly done. Scraping an entire literature from all the the top psychology journals. And now, of course, my colleagues in banking and finance say, hey, do this for finance. Hey, do this for economics. I can go, I can scrape this, and then I can see what are the differences between the different categories comparing psychological science to peer community. So you can see, for example, that the number of warnings in peer community in registered reports is lower. And then we can do all kinds of benchmarks and see trends over time and see whether we're really improving in the way that we're catching all kinds of errors with effect sizes. We can also aggregate things with effect sizes. But once we have good tools and we know how to use them, we can set them off in order to scrape everything in the literature together with an AI in order to see what happens out there. So this really gets to the point that if we have good tools, we can do good meta science. Last week, I was in Münster, Germany, because the Ford people, if you're familiar with Ford, they do a lot of very interesting things. One of the interesting things that they're doing is that they're trying to map out replications. Because the team that I had at University of Hong Kong mapped out 150 different effects with 150 replications. So they also, you can see the core team over here with Feldman, they mapped out our own replications. So Lucas over here worked with a big team in order to code things that they found with the core team, and then they came up with this big data set called Fred. Now they're working on another level called RIDA. And basically what they want is to have one place where you can find all of the replications in the literature. So every replication that comes out, Ford will be able to identify this, pull this together, and put this into this kind of thing in order to compare the original effect size with the replication effect size. Very, very valuable, but not that easy to do, unless, of course, you have a superpower. So can we do this? So a team, 20 different people came from all over the world. There were people from India, people from Chile that flew in all the way to Münster, middle of nowhere, Germany, in order to try and see, to hack together, sit together in a circle, in order to see, can we map out replications? How do we find replications? And it turns out that it's not that easy to find replications because many different replications have different keywords and they use different terms. So how do we map out all of these together? So what did I do? I used SciMeto, which is the tool that I showed you before with the references, and I added another tab for replications. And now you can see that there's like a discovery where it takes all of the wildcards and then it comes out of this. So there's for attempted replication, all of their permutations for attempted to replicate, attempted to replicate, all kinds of permutations and like what kind of weight it has on that. On top of this, there's an LLM optimizer that allows you to try out and see whether the results that you get from looking at OpenAlex and looking at all the different databases over there, how do we get all the replications? So something that is very simple. We should have solved this long time ago in science, whether we can map replications or not. Now we need to build the tools, and now we're able to do this when we have AI. So this is my attempt at doing this. When I came to Innsbruck, I missed Robert by a bit, by 1 week. And when I came in, people say, hey, there's this amazing preprint called Massaging Significance in the Age of Open Science, a satirical tutorial. And I read this, and it is funny, but inside I was crying. Why was I crying? Because what he was claiming is that people adopt whatever it is that you tell them is the norm. So you say, okay, now we need pre-registration in psychology. And people are like, okay, you want pre-registration, we'll give you pre-registration. But the worry is that people are just doing this because they need to adhere to a norm, but behind the scenes they're actually playing with this. So the satire really captures really well that some people can preserve all kinds of flexibility in the background, but not really restricting the kind of flexibility that they have. So I thought to myself, this is really troubling. I want to know, are people doing this or not doing this? So what did I do? I spawned off an agent and saying, I want to scrape the entire literature. I'm going to go over all of the OSF, and I want to see the quality of all the pre-registrations. And now we have this one with a proof of concept. It's going to be sent out as a register report to try and see what is the quality of pre-registrations. It's also going to try and see all of the things that came out of an embargo. So if somebody, one of the claims is somebody might pre-register, but they might pre-register 20 different things, and they will only share the one that they thought worked out. I'm going to look at this because OSF has an embargo after 3 years, but now we can do this systematically, because to go over this as a person to code these kind of things is near impossible. But now I can set off an agent, and I can look at this, and I can scan everything in there. Now that I know that I can do this kind of thing, I'm just like, let's just scrape everything. Because I'm already scraping, might as well scrape all of the rest. So I'm looking also at part of assessment of citations. So I'm looking, how do people cite? Are people only citing the things that support their hypothesis? If they're citing, are they citing the right things? Now what I can do is that for every one of the citations, I can go and I can get the actual paper. I can tell an LLM, please summarize what this paper is actually saying and see whether the citation actually matches that or not. And turns out with a successful proof of concept that I can do this. So we can map out miscitations. Another thing that you can do is that you can look at the computational assessment. So I can go to all of the literature, psychological science, whenever there's a reference to Open Science Framework or ResearchBox or whatever people use, Figshare, GitHub, whatever, go over there, download this whole thing, and tell the AI to do best effort. Try to reproduce this best they can. It doesn't work, try to fix it. Really best effort in order to see whether things can be reproduced. Once it's reproduced, compare what it is that came out, the output, with the results section. Does it overlap or not? Now with AI, we can do this. You might think this costs a lot of money. It actually does not, because you can create all kinds of tools in order to do these kinds of things systematically and quite cheaply. And then we do, so this is one over here, data and code. But also I wanted to know what peer review looks like. Most of the peer review, I don't understand why in the year 2026, most of the peer review is closed. Doesn't make any sense to me in science, especially after a pandemic where we needed to see everything that's happening with the vaccinations and all that. We want to reassure people that the science that we're doing is solid, but not many journals do this opening peer review. Collabora does this, Peer Community in Register Reports in Psychology does this, PLOS does this. A selected few do this, but nobody has ever looked at what is it that people do in peer review. Do we know what they do in peer review? We look at specific one that we care about, but we don't have a systematic understanding. What do people do in peer review? Has it been addressed or not? So we do this kind of thing. Okay, so I'll just talk about this very, very briefly. But once I realized I can do this, we have this big team. Chini was one of the first to join me with this big team. We did a lot of replications. It's already having some impact. We published more than 50 of these things. If you want to work with us, you're very welcome to. We still have another 50 that look for early career researchers, lead researchers. We did all of this. So people come to me and they said, this is great. Why don't you do one of these Center of Open Science or Institute for Replications Nature papers? Why don't you summarize all of this? You have 150 of these things. It's time to summarize this. And my answer is, I'm very sorry. I've been trying for years to code 150 of these replications, but because they have different methods and they have different designs and they have different effect sizes, it was impossible. A team of 7 people worked on this endlessly, and we were not able to code this until the superpowered AI. It took me only a week with an AI to do something that I wasn't able to do with 7 early career researchers that know their stuff and know what we did with replications over a year. So finally, we have a little bit of a beginning of what this looks like and what this maps out like. And then I also realized we need to create more tools and more sorts of things. So for example, some of our earliest replications with my first students is in SPSS or JASP or Jamovi, but I want everything to have the highest standards of R Markdown that has everything in the manuscript reproducible. So I created a tool that allows anybody with SPSS, Stata, JASP, or Jamovi to just move everything into R Markdown. So every time I recognize that something is missing, then I convert this. The final challenge, and this is what you voted with, this thing is that I was missing Qualtrics, and I was missing Mentimeter when I moved to Innsbruck. So it turns out that I can also build tools like that by myself. So you already tried out Minttally, which is the Mentimeter kind of similar functionality. So this is the thing that you tried out together with me. It looks like it works. I use it in my own courses, and it's free. You don't need to pay anything to Mentimeter. You can go and sign up for that. But I also needed the Qualtrics. I have over 500 different surveys on Qualtrics at University of Hong Kong, but I don't have a Qualtrics license, and this costs, it's absolutely insane that we spend this much money. It could be $5,000 for you to have this kind of thing. So what did I do? I created a survey platform called SurveyVolt. It imports your Qualtrics, and it does all the stuff that Qualtrics does. Many times in Qualtrics, I needed some functionality, and I didn't have this. Now I added this. So it does all sorts of exciting things beyond Qualtrics. If you need something in there, just let me know. I spawn off an agent, comes back, it does things to me. Last thing I will say is about risks. So I know that people are hesitant. When they think about AI, they think about, we don't know what's happening in there. It's a black box. It has hallucinations. People use it for bad. There's all sorts of things that we need to worry about when it comes to AI. And I tell you, you're right. There's lots of things to worry about. But all the things that you need to worry about with AIs, I also worry about with humans. And because I worked with a lot of students and a lot of early career researchers and even senior researchers, they hallucinate. They take shortcuts. You never know exactly whether you can trust them or not. I've coded a lot of meta-analysis. Oh my gosh, the number of errors that I find in there. People who say, let's just do human coders and we're going to solve everything with human coders, I say, not necessarily. If you've ever tried to code a meta-analysis or do any project with people, you realize humans have, they're also a black box. They have their weaknesses and biases. So I treat LLMs in the same way that I treat humans. You need a workflow and you need a process. Once you nail this down, you're able to get quality that at least as good as humans, but without all of the time and without all of the resources and investment and the money and the funding that you need into this. A lot of the things that we consider to be dirty work that we don't like to do to code a meta-analysis, who likes to go and check for what correlation in the table is there? Now we can outsource this in order to get the LLMs to do this. So how do I do this kind of stuff with all of these tools? Claude Opus 4.7, and then I have ChatGPT, Codex 5.5, verifying, checking each other. Gemini comes in and does consistency, and then we improve these things together. So if you create a workflow, if you nail down the process, then you can get things that are very, very accurate, as good, if not a lot better, and a lot cheaper, and a lot faster than doing this with humans. Summary, and this is the main point to you, a lot is possible. We can have superpowers. If you're just using ChatGPT with some chat interface, you're losing out. There's lots of different tutorials. When I was moving between Hong Kong to Innsbruck, I spent a lot of time on YouTube to see how people are developing these kind of things. And I'm learning things every day. Every week comes out a new model that just blows my mind in what is different, what is possible. This is the time for us to discuss these things. So there's a reason why I go around telling people about this, inviting people to check out these tools, to sit together with me. If I, with very little development experience, can do all of that within a few months, can you imagine what we can do if we come together in order to build these things? Finally, we can boost science from whatever broken system it is right now to something that everything is verifiable, everything is testable. We can show real performance improvement. We can build the infrastructure in order to make everything more credible and trustworthy. Everything that I do is on my website. I'm very happy to discuss with you. I'm not too far away in Innsbruck. I'm going to come back to Vienna. If not, we're going to do a call, video, chat, whatever you want. Just send me an email. Even if I'm too busy, I'll disconnect you with some other people in the group that do similar things. I'm very passionate about this. I'm very eager to try and work out with you what is it that you need, what's missing for you, what kind of possibilities that you see in order to broaden my perspective and my scope. If you have any questions, I'm very happy to answer.
Things that you have like little coding background, but somehow you have to make sure that that LLM coding for you makes sense. How do you count that?
Yeah, so when you say, so first of all, not completely accurate. Before I became an academic, I did software development. So I know a little bit about this. But in the last few years, most of my coding was R and Python. This is like the extent of my coding. But I feel very comfortable with code. If I see a code, I don't run away. It's fine. It doesn't scare me. But I think that with these websites, these are hundreds of thousands of lines of code that no one human and not even a team of humans can go over. And then the question is, how can you make sure that this works? So one of the things, for example, that I do is, and you learn this with time, for every one of these websites, there's a very, very big suite of quality assurance tests that take them through every possible edge case that you can imagine. Over time, there's also when I build skills, which is the basic component, you build a skill, it's a self-improving skill. So every time there's an added functionality, there's also need to come up with a testing suite. And one of the nice things that it does everything that I've seen in my past with a QA person. So agents can now open a Chromium browser. They can click through things. They can log in through things. You can even do a stress test. So for example, Minttally, the one that you used, how do you know that this works with 30 people? How do you use the 300? I see 300 browsers opening up. The LLM does everything. And in addition, I try to do things as deterministically as possible. So I want things to be reproducible. So instead of telling the LLM, you do this now, I say to the LLM, you create a reproducible deterministic script that takes care of all of these things together so that I can evaluate this. Then, after this is created by Claude, I say, hey, ChatGPT, please go over this and make sure that Claude did a good job. Then I get Gemini and say, hey, please. So they improve each other together, which is very similar to the process that I remember from 20 years ago when I was a software developer team leader. So there is a way of structuring this whole thing. I just treat them a little bit like I do humans. So I don't just trust humans. It's like, you just do whatever QA you want. No. You write all of this with, I want to see all of these tests. I want somebody else from QA to go over this. So everything you just need to structure. After you start developing these things, you realize you need a code reviewer, you need a QA, you need a documentation person in order to make sure that the documentation is up. You need a deployment person. I never knew how to deploy these kinds of websites. There's a lot of deployment here, domains that you need to handle. There's a lot of things that you need to juggle. After you create one or two websites, you become really, really good at this. It's not perfect, but for what a one person can do, this is really amazing. Yes.
Regarding the site. When you set torture phrases and automatically order data, what stops people from using this tool? Because to me, since it's a fraud, I made up a fake paper that I put solutions of that. Make sure that all the products match that.
Yeah. I like this because I spend a lot of time thinking about this. Now we have this concern because we're really overburdened with peer review, and sometimes we get all these amazing manuscripts that look almost perfect. They look like a person created these things, and they were created by an AI. The AIs are getting so good, so it's difficult to know whether this was created by a person or this is created by an AI. So I spend a lot of time thinking about this, but I've already seen a few evolutions. So when I got really excited about AI was when Opus 4.5 came out about 8 months ago. Since then, Opus 4.6 came out, and then came out 4.7. And every time, it seems like the new models have almost an exponential jump in capability. So whenever you take a manuscript that was simulated to be a human by Claude 4.5, you give it to 4.6, 4.6 says, oh, I can see what this AI did. It's an AI. And then when 4.7 came out and I give it something that I created with 4.6, it says, oh, 4.6 messed up because it thought that humans do this, but actually I can see that this is an AI. So one of the claims that I have an opinion piece about, is that actually fraud is going to become, assuming that there's open science and we share everything about what's been done, I think that fraud is going to become less and less of an opportunity because every time a new model comes up, it's exponentially better in capabilities and able to detect what it is that the previous model was stupid enough to do. So it used to be that you committed fraud, and then you waited 20 years, maybe somebody will find you. If not, you got your tenure and you got your position. But now, if you commit fraud, the time that it takes for this to be discovered, assuming the increase in exponential growth for whatever it is that's happening in technology, then it's going to take less and less time for the new model to detect that this was an issue. So This is possible. I did simulations about this. I have a whole argument about how this happens, but it does have one major assumption. And the assumption is you have to have open materials, data, and the code, and you need to have everything shared in order to allow the new AI that comes out in a month or 2 months in order to be able to go over everything and have some kind of signals or indications that this is done by an AI. It could be that at some point it's going to become so good that we're not going to be able to determine anymore what is an AI and what is not. And then the question is, if we can't determine what is the difference between an AI and a human, then why is that important? Yeah, if the AIs can do just as good as humans, the question is, of course, about fraud, but if it can simulate participants, let's say synthetic, but it says something really fundamental about participants that we can observe in real life, maybe that's good. Maybe we got to the point where we don't need human participants anymore. I don't know. But until this happens, I think we're going to be able to detect fraud better, especially when we have superpowers like this, easier, faster, until it doesn't matter anymore. This is my main argument, assuming open science from beginning to end. Yeah. No. Abuse.
Yeah. Clinical trials.
Yeah.
But I see.
Yeah, I don't have, so this is a blind faith. It needs to be like everything that I am saying, all this needs to be determined empirically, right? We need to put this to the test, but we need to be thinking about these kinds of threats because this is becoming, it's already happening. When we have this peer review over all these, all of these papers, do we know whether something happens or not? But honestly, even in my peer review, I would say 80% of what it is that I do with AI. It used to be that I ran everything through my reproducibility in order to see that everything checks out. And then I got really frustrated because it was this version of a library instead of that version of it. Now, the AI solve everything for me. So both the creation and the checks are going to become as good. And it's a cat-mouse kind of like who is faster, who is better. But I believe that at least our ability, especially if we see this improvement in AI, it's going to be easier to catch these things, but we'll see.
Yeah. One more question to that. If you assume that researchers give this more and more accurate means that your problem of it, that's fraudulent. That's the researchers and AI.
Yes, it's a big concern. We need to start talking about these things. I feel like most people who read about this phenomena have not experienced this themselves. So it's only until you are able to create with an AI something that is as good as a human, only then do you really realize the level of threat. I didn't go into this, but one of the reasons why I started playing with these kinds of things is that transitioning from Hong Kong to Innsbruck, I said, now I have some time to reflect about what it is that I'm doing. So what did I do? I went to Kenya. In Kenya, I thought I'm going to learn about what it is that they're doing over there because effective altruism and all of the charities are there. And then I want to understand how they're helping people in poverty and in health. And when I came to Kenya, I realized, first of all, US aid stopped, Trump and all this, like 80% of the funding is gone, so a lot of people being fired. But one of the most remarkable things is that all of the effective altruism people stopped working on health and poverty and moved into what? Looking at existential threats through AI, because they really feel like in a year or two, when we get AGI, which we get this like superpower, it's going to dominate everything that we do in our lives. So we need to do this responsibly and morally. So suddenly you have the best minds in the world that used to do charitable giving are going to AI. So I was there in Kenya, very confused about this, and say, if they think that this is a threat, it can't be the ChatGPT chat interface that I tried with the hallucinated references. It has to be more than that. That's when I started playing with these things in order to see what is it that they're so scared about. So I see a lot of potential, but I also see tremendous risks. And we really need to think about this as a community. But we need to try these things for ourselves in order to see how far we can go with this and then assess the risks and then try to come up with solutions. But I don't have a good answer for this. The best minds in the world are not trying to tackle this thing. It's also a rat race. Who is going to get there first and what's going to happen? But other things like what is our value? Can we stop fraud? What is AI going to be used for? Not just by researchers, but by government. You know, there's all this discussion in the US whether the CIA and NSA should be using AI, should Anthropic give them the capabilities to do whatever they want. We don't know. Who should be deciding these kind of things? I feel like as academics, we should come in to contribute to this kind of discussion. They're good questions, for sure.
I know you mentioned your process that when you develop using AI, you follow this process and you run one model produced to another. Yes. And I'm also like quite a convert and I use coding assistant and cloud code. So I just wanted your view on the strengths and weaknesses of the various tools that are out there. So I only use Docpluck. I usually use VS Code with GPT as the pro thing, but when I switched to Docpluck, I found that it's even better and even more. I have to think from a higher level of abstraction. So it reduces the friction even further. So
Yes.
I know you try out one with the other, but strengths and weaknesses of various tools.
Yeah. The only thing I can give you guarantee about is that whatever answer I give you now is going to be irrelevant tomorrow. Because really, when Opus 4.5 came out, it blew my mind. There was nothing even close to it. And then not too long, so it took a week for ChatGPT to respond, and then it came out with its own thing. 4.7 came out, Opus 4.7, I thought to myself, this is remarkable. A week later, ChatGPT 5.5 Codex came out. And it seems like at different points in time, they're good with different kinds of things. The main recommendation that I have for you, and actually all the open source stuff that comes from men in China and some of the other places in the world is not that far behind, and it's usually a lot cheaper. And the more that you play with these things, the more you realize you just need to have many of these things. So you get the synergy. Don't just focus on Opus. Don't just focus on Codex. Don't just focus on whatever model from China. Have all of these validate each other, just like you do in a team. You don't rely on this one person to do everything, all of the coding in a meta-analysis. You have inter-rater reliability, right? And then if they come to a consensus, perfect. If they have some disagreements, they can consult with you, and you can decide what works best, and then they improve their prompts. It's not only about which tool you use, but how well you prompt it. What are you using? Is this kind of skill? So for example, there is a skill called superpowers that you can install that actually takes Claude and Codex and all of the rest to a whole new level. Sometimes memory is missing, so you have a different component. So it's not just about which tool are you using, but also what's called the harness and what's called the infrastructure. So over time, you generally need to know that you need to spread wide and have checks and balances, just like you do with humans.
Question, but it's not a question. I just don't know how to phrase it in a good way. But first of all, I'm really scared about AI in the sense where it will lead us. But I also tell my students to use AI because, as you said, if you don't use it, you don't know what we are doing with. So we need to learn. We need to know it. But now I'm seeing it more and more. Okay, so like I said, universities are like a team of people. But what do we do with people that we don't need? What do we do with sources of AI? What also concerns me a bit, like, what do you think about that? I'm sure it will go into the directions that we can
Yeah. Many times I ask myself, what is my value here? Maybe I can code a skill that would just replace me and then just do all of these things without me. And I think maybe not too far away into the future, it might be possible that my value goes down. But I think my value is more likely to be higher if I know how to use these things than if I don't know how to use these things. Generally, how I think about these LLMs as a tool, I think just LLMs help us understand how much we don't understand. So I'll give you an example. I didn't really think about these kinds of things, but when you do a t-test in R or in Python, what do? You use a library that does all kinds of things. Did you go into the library to check whether this does what it... When you run R, did you check all of the C++ code that runs underneath? When you run an IDE, did you check that VS Code really does and execute everything? When you have a debugger, did you check that? We have a lot of things that we rely on checks and balances. Now we have a way to systematically check and recheck with the very different models in order to make sure that our tools are better. One of the first things that I did is to look at all the libraries that compute an effect size, let's say a Cohen's d, whether they give you the same results. What do you know? They really don't. Because they have different assumptions. Now I can test this very, very easily. Before that, I didn't even think about, pivoting this library versus this library in R versus Python versus SPSS. But when we start doing this, we realize, first of all, we have errors. Second of all, we've trusted this infrastructure without ever peeking under the hood to see what it is that they're doing. LLMs take this to a much more extreme level, but there is a way to do this better. So that's why whenever I develop with an AI, I always tell it, please create a deterministic code of what it is that you're doing. And then I try to improve the deterministic code as much as possible, just like I would do with a human. But now I have this ability to take other LLMs in order to check this kind of thing. So it used to be, for example, with a meta-analysis, we used to code a lot of effect sizes, and I would tell my collaborators, please copy-paste the context from which you discover the effect size. And then some of them would do this, some of them would not, some of them, it depends, and bad code copy pasting. With LLMs, I can tell them whatever reproducibility I want in order to code these kinds of things, and then I can get others to check this. So we're proving capabilities, but in terms of trust, what we can verify, how much we can do, lots of challenges, but at the very least, we need to understand that these gaps exist, and then we need to think together how to tackle them.
I want to bring up what I consider the biggest risk around AI, which I rarely do mention. I think it's more, it's less the non-support than less things. I think it's more that we become very dependent on these big tech companies with the data sets. Yeah, we put out the models, and really there's nothing stopping them from going 2 years maybe, and we could already see recently with the Olympics conversation that they just say, we won't give out our best models, or we won't sell you the models for the same price. And I think the risk of outsourcing and what keeps the companies from just exploding.
Yeah, it's funny because I think like these LLM AI companies just make a lot stronger something that already exists. Try and not use Windows. Try and not use Google Maps. Try not use Gmail. Try and move away from any of what these big companies are doing. We become very dependent on them, whatever it is that they demand of us. So they use all of your privacy in order to make unimaginable profits off of you. They use your data for all kinds of things. And we just went along with this. You would have expected that we would have stood up and done something against this. We should have. Now with these LLMs, the problem is it can really dominate. So it's not only just like mail and maps and I don't know, whatever it is that we use in order to do search, but now it can dominate all of the aspects in our lives. So this becomes an even bigger problem. So I think what we need to do is, first of all, learn from the past to understand that we have the same kind of predicament that we did before on a much larger scale. So we need to ensure that there is competition and that there is transparency. And when a new open source model comes from China, and I say, oh, the Chinese are evil, now we can't use this kind of thing because we trust Anthropic or we use OpenAI, I'm all for competition. And let's put arenas together and see which one gives you the best possible. If we leave everything for this, OpenAI started up as a nonprofit, and then they shifted into this for-profit model. We in academia need to come with some solutions. If you don't like Mentimeter, create your Minttally. If you don't like Qualtrics, create SurveyVolt. If you don't like what these companies are doing, build your own. Because none of what they're doing is very new. If the Chinese can do this as efficiently, if not much better, for much cheaper, then we could as well. We don't need to wait for these companies in order to get our act together and do something about this. But we need to at least have this conversation. Very good risk to map. We need to see what happened before, and we need to try and prevent this in the future. As much competition as possible, as many solutions as possible. And if one of them closes down and doesn't want to give us Smithers, then perhaps the next Chinese model, when is going to come up and give us what it is that we need. But we need more and more of these companies, and we don't need to just like silo all of the GPUs or whatever. That's why we need an open competition and involve academics as much as possible now when it's crucial.
There's one more response to that. There's this startup in Vienna called Minttally AI, which is coming up recently. And what they're doing is trying to make AI, like, they have a sovereign AI lab. So they are trying to make it easier for companies and institutions to have GPUs on premises and run query models and other models that are almost as good, and try to bridge the gap between the cloud and APIs and Anthropic and US usage versus the on-premises. Because some of the companies, like the journalism company, they want their data to be protected. So they are pushing for sovereign AI in. So we can switch to these if that's the way. I know the models aren't that good, but they are coming up, the web models.
Sure. I think the AI, this is way bigger than the original. So the very random estimate of the next model, new models by traditional tools, it's called still go as open source and still go to the old versions run or operate existing by them still run a Linux version from people, but I can't access this whole box. So this paper. Previous one.
Yeah, we have a lot of concerns. I think one of the things that we need to do is to map all these concerns. I listen to a lot of podcasts. Some of them are interviews 2-3 hours with the best minds out there in order to understand all the risks. So what happens when these coding agents become so good at coding that they can change their own code? And then who needs us anymore? And then it's exponential, and then they do whatever they want. What happens if an authoritarian regime gets the best model out there and then he does whatever he does in order to dominate all of the world? What happens if? This is why we need people to step in, to be involved, and to do as much as possible. Lots of different risks, for sure. So we need to understand this technology, and we need to see what's possible. But we don't need to shy away from this. We need to leverage this for good as long as it's happening. It's unavoidable.